It and go back to the main presentation. Right, so hopefully you can see this. Home networking. So, usual open pages. Oh, I've added the buy me a coffee link at the bottom there. I mean, I will say it because there's some new members here. Since retiring, I've really on this group created a new presentation a month. And so the number of presentations has got bigger and bigger, obviously. And I'm more than happy to redo these talks to any local Third Age Trust U3A group. My personal webpage is at the top there, plord.co.uk/talks, and you can see the list of talks that's in there. So that's what I thought we'd talk about today. And as usual, the main purpose of the slides is not to lecture, but to stimulate discussions. So usually I'm looking for quite a bit of discussions after the talk. So I'll start off with basic broadband. And I did think about, should we go back in time and talk about dial-up networking and all this sort of stuff? No. Let's just think about what happens today. So I'm starting with basic broadband, having some words about Wi-Fi, some words about Ethernet, a bit about firewalls and security, inbound connections, and then some other options that you might want to look at. So I don't have a great deal of slides. So I do have two screens here. So if you want to interrupt me, feel free to do so. So basic broadband. So this is what happens. Okay, so you go online and you search for what ISP is going to provide me with broadband. And you sign up with someone and they deliver you a box. And that box is basically a link between some connection that connects you to the internet on this side and gives you a Wi-Fi network on your home. So this is the box they provide you with. It's usually a very general purpose box. It's a router. So it routes between two networks. So any data in here is, goes through a firewall and is mirrored here. So it means that once you've got this set up, you plugged it into the wall, then you turn it on, you perhaps need to register, and then all your devices in your home can connect to the Wi-Fi network and connect to the internet. Now, of course, all different types of broadband you can get. I suppose the original one was ADSL, asymmetric digital subscriber line, and this was a broadband over the BT telephone network. And I've never had it myself, but I understand the cable comes into your house, comes to a little box. You plug your phone in as normal into one side, and you plug your router into the other, and that gives you your broadband. So, for example, OpenReach. Lots of other ways to do this, of course. You can do it by satellite. Now, as most of you know, I do volunteering at festivals over the summer, and typically someone brings along, would you believe, a Starlink satellite dish so that little group of tents can hook on to and get their network. And yeah, so over the summer I was on Starlink, Elon Musk's broadband service via satellites. Or it could be on a mobile network. I've got a little box here actually just beside me, which I'm about to donate to a friend. So instead of having a physical cable, much like the satellite, you plug a SIM into your router, and then your router on one side talks to the mobile network, 4G, 5G, whatever it might be, and then gives you Wi-Fi in your house. Cable modems are very popular.
That's what we've got, cable.
You got cable, yeah. So,
Oh, sorry, I didn't realise that my
that's all right. So cable, for example, Virgin Media, the old style Virgin Media, what you do, you get a coax that comes into your house, that plugs into the back of your cable modem, and you've got a box. It doesn't look like this, but it gives you Wi-Fi onto your home. Virgin Media now also supply fiber direct to your home. And of course, you can have fiber. And in the fiber case, you actually have a piece, little tiny piece of fiber cable that actually comes directly into your house. And this is what I've got at the moment. So this is what I'm pretty familiar with. I'm connected via City Fiber, and I actually use an ISP called Tube over City Fiber. So lots of different ways that you can plug in your router to your broadband supplier, but however you do it, the principles are the same. You've got this box that sits between your provider and your home, and in your home, you use a Wi-Fi network to access the internet. Now, it's not the only way. So if you have a look on the back of these boxes, you'll have, I've got a picture actually a bit later, what's called Ethernet, yeah, Ethernet ports. And you use a cable like these ones here, look like a bigger version of the telephone cable, RJ45 connectors. And you can connect a cable from your router directly into a PC. Now that's often a very good option because that cable there is not going to suffer from the same problems that your Wi-Fi network would have. If there's a huge distance between your router and where you're trying to access it, because Wi-Fi is a radio signal, that's going to decrease over distance. And if you go to the end of your garden or something, you're going to get very poor performance on Wi-Fi. But however, if you use a cable, then that doesn't have that effect. It doesn't get, it's not a radio frequency, it's a piece of copper, so it doesn't drop with distance. So very often people, if they're working from home, they might have a PC at home, they might plug that directly in the back of the hub to get maximum speed. And then all other devices at home, their tablets and phones and so on, they'll access those over Wi-Fi. So Wi-Fi is not the only option. Ethernet is an option. My house has got Ethernet cables all over the place. Okay, so some general characteristics of different types of broadbands coming into your house. Now, of course, it depends on what level of package you agree to buy, how close you are to your 4G or 5G mast, lots of variations. But, broadly, we have ADSL over your telephone line, roughly about 11 megabits per second download speed. Now, megabits per second is just a measure of speed. We don't need to go into too much detail. So the higher, the better. The higher speed, the higher megabits per second, the faster you can download things. But also, of course, often you're uploading things. If you want to share something with or send an email, you need to do uploads. And very typically, the upload speed is significantly slower than the download speed. And that is, casually browsing the internet, you're mostly downloading stuff. So that does need to be fast, but upload, for most people, it matters less. The other measure I've got here is latency. And this is the speed that the network will reply to you. So speed and latency are very different mechanisms. You can imagine the difference between, say, a Porsche and a truck. So a Porsche can run really fast and it can get there quickly, but it can't carry much in its boot. Whereas a truck can cover huge amounts of load, but it's going to get there slower. So the time to get there and how much capacity you've got are kind of quite different measurements. So generally what you're looking for is high upload speed, high download speed, and low latency. Lower the latency is better. So satellite, I mean, as I said, I was in the field over the summer testing this stuff out, sat on my tent, doing speed tests, knowing I was going to do this talk. And it's surprisingly fast, actually, in a field. Again, the upload speed is much shorter and the latency is quite relatively high compared with these others. Because, of course, the data, if you're downloading it, it's going to come from, say, I don't know, New York. It's going to go to the internet center in New York. It's going to go up to a satellite. It's going to come down to a satellite before it gets you. It goes a long way before it gets you. So that's almost like a measure of distance these signals have to pass.
Peter, I thought latency was just simply the time delay from you sending the message to when it's received.
Yes, that is correct. Yeah, it's the time. I hope maybe I didn't describe that very well. I'll go through in this a little bit more detail in a minute when I start to look at tools and pings and so on. But you're absolutely right. The latency is the time it takes for a packet to go from where you are from where it's coming from to where you are. It's a time delay. So Porsche will have a very low latency and a truck will have a very high latency. That's the inverse of speed, if you like, when you compare with a car. Mobile broadband. This is an interesting one because I bought a mobile broadband which does 4G plus. Now 4G plus, the plus bit applies that you can have multiple aerials working concurrently. And testing as well, if you're quite close to a mobile broadband mast, you can actually get quite high throughput, significantly faster than ADSL anyway. This can go up to, easily 500 megabits per second on 4G plus or 5G. But the upload on mobile tends to be quite low. And better latency I found when I did some tests. Cable, like, Virgin Media, depends what package you buy with cable, but they tend to give a very fixed speed. If you buy 500 megabits per second, you get 500 megabits per second. Virgin Media has a policy of 10 to 1. So if your download speed is 1,000 megabits per second, stupidly fast, then the upload speed is usually a tenth of that. And the latency on cable tends to be significantly lower. And finally, fiber, the new kid on the block, as you like. This tends to be, the currently almost the lowest package you can buy is close to 1,000 megabits per second. But unusually, fiber tends to be symmetrical. So both download and upload the same sorts of speed, and you get this very low, or should get this very low latency. Peter.
You said mobile. Are you talking about a mobile handset or Three's offering where you get a box from Three and it basically plugs into your network? Is that what you mean by mobile?
Let me just disconnect and show you one. This is one. This is a mobile. Hopefully you can see this is a mobile router. And at the bottom, I can get the blinking thing off. It's got a SIM card.
Okay.
So you buy a SIM card, you buy one of these, and it gives you broadband access.
So, but the offering from Three is a different shaped box. Have you heard? They're offering speeds maybe 150 two ways. Well, quite fast actually. I'm just wondering, has anybody got the Three offering at all, please?
I used to use it, yes. So
okay.
I used to use it as I live in the absolute middle of nowhere, so I was using the three network for some time. I guess the thing we probably may come on to, but there is on various of these technologies, there's contention problems. So you can get a very, very fast mobile connection until all the kids come out of school. And then suddenly it all stops. And I moved from Three onto Starlink, and at the time, there's a lot more satellites around now. At the time, I was having the same problem. That there was definitely a contention problem with the Starlink system.
Yeah, we'll come on to measuring the performance of broadband
Thanks
in a
very
minute.
much. Thanks very much. I know somebody's got one and they seem to be okay. I just wondered if anybody. That's interesting. Thank you.
Paul.
Yeah, hi, Peter. I was just wondering, when you say it's much more symmetric now, which it is it simultaneous or is it transmit and then go to receive mode, or can you be doing gigabit per second on both at the same time?
That's a really interesting question. I really don't know.
Not that you
Oh.
usually would be in terms of the way you use the internet, but I'm thinking of people like gamers and people that are doing stuff in real time control systems and that.
I
Yeah,
can provide an answer to that, Peter.
Go then.
Being an ex-hardware engineer, when they put fibre in for me, I went and had a very good look at what was happening. So there's two. You have a downstream line and an upstream line. So in theory, they are completely independent.
Okay.
So you can run equally in both directions. The main trouble is certainly the BT consumer story does not give you does not have a symmetrical offering. You've actually got to go for their business fiber to actually get symmetrical. At least it was last time I checked.
Okay.
Yeah, so you've got light packets going both way on the fibre at the same time then. There's
two fibers. So you have a fiber coming down.
Okay, yeah. Because the other way is to multiplex, isn't it?
That's right. So one's a multiplex and one's effectively you get everyone else's data as well, but it's all encrypted.
Yeah. Effectively VPN to them.
Yeah.
Thank you.
Ray.
Yes, I was just actually going to say, around here, although we've got fibre in the street, they're only offering the up to 1,000 up and only 1,000 down and only 100 up. We're not getting the option of the symmetrical fibre around here. The other snippet is a mobile phone could be used as a 3G sort of modem or 5G. And in fact, my Asus router, probably the same with yours, has actually got a USB socket, so you can tether the mobile to it to use that as a source. So that's just 2 pennies worth.
Yeah, good point. And of course, in that case, when you're tethering with your phone's connected to 4G on one side and Wi-Fi on the other. It is exactly as the diagram we had. It's behaving as a router. John.
Well, actually, the tethering's done via the USB lead, so it's hardwired from the phone to the modem.
Yeah, you don't have to though. You can use Bluetooth and Wi-Fi combined to tether as well.
John.
Heats your phone up sometimes. And the battery.
You're muted, John.
I've got.
You're still muted.
It's just not talking.
Sorry, John, we can't hear you.
Okay, sorry, I was just trying to. In my panic, I'd missed out there. I've got one of those.
Can't see what one of those is.
It's a BT gadget, and it's not connected to the phone line or anything.
So what's it connected to? Is it connected to the mobile
I
network?
think it's just connected to the internet, to the signal coming into the.
It looks very much like the normal 3G, 4G, 5G telecoms modem. You connect to that via Wi-Fi, right?
It's not connected to the phone.
Yeah, but you will connect to that using the Wi-Fi.
Yeah. Thank you, Peter.
Yeah. Sorry, I'm muted. Okay, I'm there. Right. It's interesting. I've seen two offerings with the fibre now. One offering automatically comes with voice as well, because with the fibre you lose the voice connection, as you know, unless you pay for it. So the interesting thing about the fibre is that they are splitting the costs between. Sometimes you get the voice thrown in, and sometimes you have to pay extra for the voice.
Yes, so
have that experience as well.
Yes. So if you're coming from a supplier that supplies voice, such as BT or Virgin Media, moving to fibre is quite a jump because the fibre doesn't support voice. So some companies will give you a package, which is they'll give you a voice over IP phone, which is an IP type phone. which is just connected to instead of having an analog connection, it will use the digital connection to ring. And I'll touch on that in a minute. But what I'd recommend to you, actually, if you're looking to move to fiber, is that you go to an independent voice over IP company such as Andrews and Arnold, because they will be significantly cheaper. You just need to buy a little box, put it on your network, plug your phone in, and port your number over to that company. And that's what I did.
Oh, that's very interesting. I didn't know you could do that. That's very interesting indeed. Thank you for that. You're going to cover that later on a bit more if you could, are you?
Yeah, I'll mention that in a minute. Yeah.
Okay, thank you. Thank you. I'm interested in that. Thank you.
All right, John, you've got your hand up again. Do you want to mention something else?
No, I just forgot to put it down. That's
Okay. Alan.
Yeah, just one point. I've got fibre to the property and it is extremely fast. However, the service provider can sometimes limit the upload and the download speed. I get very fast download, but the upload speed is limited by the service provider.
Hold that thought, because I've got some numbers for you in a minute.
Right.
All right, so let me push on with the slides. Right, okay, so that's the general speed. And I wasn't just trying to imply that this was only, all you can get, depends on the packages you buy. So moving on. So let's have a look at some characteristics of Wi-Fi. And what's happened recently is different Wi-Fi standards have started to be given a more marketed name. And so we've got this marketing name, which is a damn sight easier to remember, to be honest. We've got marketing name Wi-Fi 1 all the way up to Wi-Fi 7 here. And these got like formal names. And if you have a look at the back of your network equipment, they probably give all these sorts of weird names, which just refer to a standard. But the marketing name is much more useful. And as time went on, we started off with Wi-Fi 1. It was on 2.4 gigahertz radio frequency and had a theoretical maximum of 11 megabits per second. So if you think that your broadband coming into your house, let's say it's at 200 megabits per second, and if your Wi-Fi is significantly slower, you can't make use of it. Your limiting factor is going to be the speed of your Wi-Fi network. But fortunately, as time goes on, we've had newer, different Wi-Fi standards. And now, if you're going to buy a Wi-Fi device, you're probably in this area here, Wi-Fi 5 or Wi-Fi 6. And these operate on, usually two different frequencies, 2.4 gigahertz and 5 gigahertz. And as you can see, this theoretical maximum, the speeds of these Wi-Fis now are really quite impressive. And just to give you a feeling, so as I mentioned before, I'm on City Fibre. And if I do my speed tests over Ethernet, I do get 950 megabits per second. Over Wi-Fi, I get about 650 megabits per second. So it's pretty damn good, just over the air. Wi-Fi 7 is an emerging standard. You can buy equipment, but they tend to be pretty expensive at the moment. And also what I wanted to mention, that if you are using Ethernet cables as well, maybe a cable from your router to your main PC, those cables come in different sorts. And these are a category of cables. So Cat5 cables is really only rated at 100 megabits per second. Cat5e is 1000 megabits per second, and Cat6 is 10,000 megabits per second. In other words, if you're going to go out and buy some Ethernet cable, because these are pretty much the same price, just buy Cat6. There's no point buying Cat5 cable anymore. I mean, my house is wired with 5e, which is just enough. No point buying old sorts of Ethernet cables now. Peter?
Why would you ever buy Wi-Fi 5? quite dangerous, isn't it? Because a lot of home automation devices run off 2.4. I'm just trying to figure out what the market for that might be, Peter.
Yeah, so if you buy a router, it will typically support lots of different standards at once. And it will support, you'll see on the box, it will support Wi-Fi 6, Wi-Fi 5, Wi-Fi 4. So older devices on your network, even your phones, may not support the latest Wi-Fi standard and therefore not go as fast as advertised. So, and my phone is what, I don't know, probably 4 years old, and it does support Wi-Fi 6. So I actually in practice get about 600 megabits per second. But older phones may not support Wi-Fi 6, you're stuck with Wi-Fi 5. So your Wi-Fi network in a home will typically support lots of these standards, say it on the side of the box, over probably 2 separate frequencies. Okay, so a little bit more on Wi-Fi. So obviously with Wi-Fi, the actual speeds that you get really you're not going to get anywhere near the maximum. It depends on the distance, if the radio frequency is going through walls, so you're not going to put your router behind your hot water tank, you're going to put your router in your house where it's going to be a good place with least obstructions. And actually a good place to put a router is in your loft in the middle of your house, because then the radio waves come downwards, either side of your walls rather than trying to go horizontally through your walls. And of course, if you're connected via cable, you don't have this problem. So even those maximum speeds can be quite impressive. In practice, you're probably not going to get anywhere near that. Now, I mentioned the 2 different frequencies that Wi-Fi can now offer at 2.4 gigahertz and 5 gigahertz. Now, 5 gigahertz can be faster. You can get faster throughput through it, but the range of 5 gigahertz is less. So 2.4 gigahertz is slower, but can go further distance. So, and also the other thing is that older devices may only support 2.4 gigahertz. So in vast majority of cases, you're going to have a router bought by delivered by your ISP, and it's going to support both frequencies. And what you want to do on your devices is, if you're fairly near your router, make sure you're operating over the 5 gigahertz band. If you're further away, then your device will automatically drop down to 2.4 probably. Now, when you get this router, on the back of it, on the bottom somewhere, it will give you a network name, Service Set Identifier, SSID. And this is usually set to random unique name. Vast majority of people I meet don't change it, but you can change it. My Wi-Fi network is always called Pete's WAN, and so it's a little bit more obvious when you start connecting your phone to your network. You get a list of networks, and you can pick yours out a bit more easily. And now there's several encryption mechanisms available over Wi-Fi. Now the problem with transmitting data over the radio network is that people can sniff the network, so you really need to encrypt things. So there's a very old encryption protocol called Wired Equivalent Protocol, WEP. That is old, and if you ever have any devices using that, stop using it. This is deemed to be very insecure, very easy to hack. But we're going back, maybe 20 years. Now there's Wi-Fi protected access, WPA, which was really a quick fix for the problems for WEP. But now most people, when you go into setting this up, you'll be using WPA2 or WPA3, which is the current standard. And providing you set that for your encryption, you're going to be fine. It's incredibly unlikely that someone's going to hack your network if you're using that. First, one thing to say that not everyone's aware of, these routers will usually support what's called a Wi-Fi protected setup, or WPS. And so usually there's like a little button on the router, usually called WPS, And if you press that button, it enables devices to connect to your network without, bothering to type in a password. And it's only active for, 20 seconds or something. But it's like a quick way to get onto your network without bothering with typing in your passwords. One thing you might want to think about is having a guest Wi-Fi network. So you can usually enable that on your router. So effectively your router is giving you two separate networks. It's giving you a nice secure network that you're going to use yourself and do all your financial billing stuff. And then when someone comes to visit you, you can give them access to the guest network. And those guests then will not be able to access the other devices on your network. All they'll be able to do is to access the internet. Right, so some tooling. So the big issue you're going to have with Wi-Fi is the signal strength is going to vary. And so being able to test your network, where it's strong, where it's weak is really quite important. And there's this tool that I've been using for years. And I believe I use it on Android. I believe there's a iPhone equivalent to it now. And it's called Wi-Fi Analyzer. And it's got lots of separate screens. And one of them just gives you your signal strength, and you can enable the sound. So you can walk around the house and it thing's going beep, 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 beep as the signal increases. So if you walk around with one of these tools, you can see how good the Wi-Fi is in different parts of the house. Maybe you spend a lot of your time sat in the conservatory, you test it in conservatory, really poor performance, which is telling you that maybe you need to move the router perhaps somewhere near your conservatory. And just while I'm here, you might be able to see if you've got good glasses, this is a screenshot of my phone, and you can actually see a number 6 on the little Wi-Fi icon at the top. That's telling you it's on Wi-Fi 6. And these little tools, this Wi-Fi Analyzer is not the only tool in the book, but it'll also show you the other Wi-Fi networks in your area, what channel number they're on, and a whole bunch of different information. But personally, I find just having this bleep and walk around the house is more than enough to kind of figure out how strong your Wi-Fi signal is around different parts of your house. Now, here's a new thing that I only discovered really recently. You can get these little dongles as USB-C on one side and Ethernet on the other side. You can plug this in your phone and then plug this into your router with an Ethernet cable. See, the problem is you have to think about, if you're testing your network, what are you testing? Are you testing the Wi-Fi speed, or are you testing your broadband speed? If you want to test your broadband speed, you really want to do it over Ethernet. And if your broadband speed isn't up to scratch, you test it over Ethernet, then you can complain to your ISP that it's too slow. If, however, your Wi-Fi is slow and your broadband speed with Ethernet is fast, that's telling you there's a problem in your house with Wi-Fi. So test on Ethernet, test with Wi-Fi, using the right tools will kind of give you some clues about where the slow speeds are. Ping, we mentioned latency. There's an decades old tool that's available on all operating systems, and it's called Ping. Now, Ping is the name of a command, and what that command will do, it will send out a test Ethernet packet to some remote site. That remote site will respond with an answer, and the Ping tool will actually give you the time, the latency for that response to come back. And this is the command line version. And of course, you can get applications that have got Ping in nice graphical formats, but it started off as a command line tool. So here I've typed in ping bbc.co.uk, and we can see individual packets coming back, and we can see the time each packet's coming back. And it gives you a nice summary at the bottom. It gives you, for example, the average round trip time, 7.9 milliseconds in this case. And the other thing you're looking for is packet loss, in this case, 0 packet loss. So if you're getting dodgy connections, try Ping, and it'll give you, hopefully your latency will be nice and low, and you should certainly look for 0 packet loss. And I said, there's other graphical tools to do that, but ping can give you actually a surprising amount of information. And of course, we all know about the different speed test apps. You can have them on your phone, in your browser, applications and so on. And what that will do, it will try some uploads and downloads, and will give you, your download speed, your upload speed, and it'll also give you your ping time, average 5 milliseconds. Jitter is kind of quite interesting. Jitter is a measure for how variable the network is. So really you want a very low jitter as well. If your network is, 5 milliseconds, 5 milliseconds, 20 milliseconds, 5 milliseconds, that's got a high jitter because the latency is varying. So when you're testing, you're looking for nice high speeds. You're looking for low ping times or latencies, low jitter, and of course, no loss. You don't want to be losing any data. Okay, so we probably talked about some of this already, but improving Wi-Fi speeds. What can you do then if you've taken your mobile phone with a little device, little app that's measuring the speed, and you found out that in the conservatory you're getting really poor performance? What can you do? Well, there's a few things. As mentioned before, if you've got slow speed over Wi-Fi, then try using Ethernet. And this is probably the desirable option if you're working from home on a desktop PC and you want guaranteed speeds on that machine because you're really doing some work, or you're doing lots of video editing or stuff like that. Put it on a cable. That's going to be your best bet. So what else can you do? Sometimes you can put to one side the router that your ISP has provided and buy your own. Now, what I found is the routers that the ISP provides are usually like just enough. There's no free capacity there at all. And also it depends on how you're connecting. So on fiber, for example, you can authenticate to the fiber in two ways. You can use a protocol called PPP, point-to-point protocol, or you can authenticate with DHCP. Now, the problem with PPP is it's a compression decompression type protocol. All packets are going to be compressed and decompressed. So if your ISP says you must use PPP, your poor old router, if you're doing high throughput work, this router is going to start getting hot and it's going to start slowing down because all this compression and decompression is really too much for it. So anyway, you might be able to put your router aside and buy your own. Now, you're not going to be able to do this if you're on cable modems, because you can't go to Amazon and buy a router that's got a connection to the Virgin Media network. You'll probably be able to do this if you've got an ADSL network. You'll probably be able to do this if you've got a fiber network. And so this is actually what I've done. The router that the company provided to me is on my shelf here somewhere, and I've actually bought replacements. And the thing is, you can see I chose this picture. It's got lots of big aerials. It's big beefy stuff. You can typically, really upgrade your router, your Wi-Fi network just by replacing your router. You will need to understand how the authentication works from your router to the network. Now, ISPs will either say, yes, feel free to use your own hardware. This is the username and password you need to set up in your router for it to work. Or they may say, no, you absolutely cannot use your own hardware. So when you're looking around for, who to supply your broadband for, one criteria might well be is using your own equipment, because that gives you more options. If you find the equipment provided doesn't have some feature that you're looking for, then you can, buy a replacement router and pick it in. You've got that option. So that's one thing you can do. Another thing you can do is to keep your existing router that's supplied by your broadband company. You can use a piece of Ethernet cable to a new router or a new Wi-Fi, now it's called an access point. Disable Wi-Fi on your original equipment that's supplied. You can go into the admin console, turn off the Wi-Fi, turn on the Wi-Fi for your new router. So you're using two now in series, but your phone is now connected to your new super powerful Wi-Fi router, and your Wi-Fi router is connected on Ethernet to your original router. And actually, this is what my daughter does. She's on Virgin Media, and she's bought actually this exact model and done exactly this. Turned off Wi-Fi there, brought a nice beefy, powerful router for Wi-Fi, and that easily supplies the Wi-Fi with our whole house. So that's one thing you can definitely do, even if your ISP, your broadband provider, says you can't provide your own equipment. Well, you can, but you need to do it in this way. The other thing you can do is have an extender. Now, there's types of extenders. This is actually called a repeater. What that will do is it will simply boost the radio frequency of your Wi-Fi. Now, this can work, but it also may not work. But these guys are pretty cheap. You know, it might be like £20 or something like that. And so a simple repeater might well be enough. The other thing you can do, I've not got this picture here, but you can buy these repeaters, which are actually connected via wires to your router, but over your mains wiring. So you can see this is obviously plugged into a main socket to get power, but if you buy them in pairs, you can actually extend perhaps a bit more successfully by having a cable effectively from your router to the repeater. So, you know, if you've got low power, low signal strength in your conservatory, you might be able to buy one of these, plug it in your conservatory, and get boost your Wi-Fi signal. However, the better way to do it. Oh, yes. So these are the main ways. I've got a better way in a minute. So use a cable, replace a router with a better one, add a new router and disable Wi-Fi on the original router, or use an extender or repeater. But a better way, far better way in my view, is to use what's called a mesh. Now you can buy usually an additional router, or probably of the same type, connect them together, usually via a cable, but configure them as a mesh. In other words, these two will work together to provide Wi-Fi signal. So the idea is you might put one at one side of your house and have the other side of the house. And what happens then is anyone using the Wi-Fi signal will effectively roam. They'll connect to the nearest, most powerful router. And the protocols between them will actually manage devices as your phone moves around the house. Neil, you got your hand up.
Yeah, just one point there, Peter. So I have played around with multiple routers on the systems before and had significant problems. Basically, daisy chaining routers doesn't seem to work very well under some circumstances due to you've effectively got two network address translators running. So generally seen as being a bad idea.
You wouldn't have NAT enabled on your. So you're talking about.
Yeah, three slides. That's one. You need to disable the NATs on this. Yes. On the second one.
So the difference is that this device you get from your ISP will be a router. It'll convert this network to this network. Your additional one is just going to be an access point. It simply takes the existing network and converts it to Wi-Fi, the same network.
Yeah, so you need to make sure that's set. So you need to get deeper into the setup for that to be handled.
Yes, good point. You set this up as an access point.
Yeah. Okay, sorry, just a minor point.
That's very good point.
I have had sometimes it works, sometimes it doesn't.
Yeah, Paul.
Yeah, I've noticed, and it happens in my house because I'm on fibre to the house, and a few other people where I've helped them out. Quite rightly, I think a lot of the fibre companies now are supplying two boxes. One which is effectively a fibre stroke cable modem, with an Ethernet connection coming out of it that then goes into the router that they normally supply. But you don't have to use their router. You can just unplug it, and then you can plug your own router into the mains and connect it to the fiber modem with the Ethernet, and then you can do what you want on the network. So you don't have to tamper around turning off the Wi-Fi on their box or configuring it as a modem only, because it's all in one box.
Yep.
That they do seem to be splitting them now, and I think that's a much better way to go. Because if you want to put your own router in, it's dead simple. You just unplug theirs and plug your own in.
Yep. Yeah, I agree. And that's what I've done. In my house, I've got a little box on the wall called an ONT, an optical network terminator. So the fiber comes into that little box and it's got an Ethernet port on the other side. And as you say, you just plug in your router onto that Ethernet port on the ONT on the wall.
Yeah, and you can't change anything in, and probably quite rightly, you can't change anything in that
Exactly.
in that fiber box, but you can change things in the router they supply, or you can just plug your own router in and do what you want with it.
John.
I've got City Fibre because Wolverhampton Council, for some reason, have a contract with City Fibre, so they've been going around the whole city basically and giving everyone City Fibre for the last 2 years approximately. Interestingly enough, just going back a little bit, the box they give you a router City Fibre, and it's got actually a connection just for a standard analog phone at the back. So I presume it's got some sort of VoIP electronics inside, I presume. Never investigated it, probably can't find out anyway. But moving on, at home, I've got their router, but for various reasons, like it's not just the Wi-Fi, but the fact of having, for instance, software ports on computers, right, to direct particular applications. So, for instance, I've got WireGuide on an old mini desktop, which uses, I can't remember, certain ports. So obviously, I direct the ports through the router to that, and because I might sometimes change from the existing ISP TalkTalk, I've got, as you said, the TalkTalk router, which City Fibre provided, and I've just done the wired connection to my own TP-Link router, which I think is about £60. So it's much better than the TalkTalk, and also it gives you this. It's a better interface for directing certain ports from the router to particular computers. But
we'll come on to TCP ports in a moment.
But obviously, part of that, I have got an original extender, so the router's upstairs where this computer is, and they're fine. But downstairs, through the thick walls, particularly if you go outside into the porch, say, the signal just drops off. So I've got one of these, as you said, extenders, and it just gives you another network with the EXT shoved on the back end of the network name, but it gives you the same password if you use the WPS buttons, as you said.
Yeah.
And then for my daughter's house, it's really strange. She's got Zen, and I tried to do the same thing, having another router, but I just couldn't get it through to work for some reason with Zen. I think Zen are a bit peculiar. They use a router called a Fritzy box, which I remember seeing years ago in Germany, and it gave no end of trouble there. And anyway, so that doesn't seem to work. So as you said, I got a mesh network for her, i.e. 3 mesh devices, one connected by Ethernet to the Fritzy box router, and then the other 2 at different places in the house, which connect wirelessly and as you move around, which seems to work very well. Yeah. Okay, back to you.
Okay, thank you. So a little bit more on broadband supplier selection. So this will resonate with some of the comments already had. So first thing I'd say is think about what you need. And 25 megabits per second is more than enough to stream 4K video. So those are looking at like 1,000 megabits per second, like me, it's just bonkers speed, really. it's going to be way more than you need. You might want specifically low latencies, particularly things like gaming. Low latency might be. So, think about what you need. There's no point paying more than what you need. However, having said that, if you move to fiber, it's actually quite hard to get a slow fiber package. And some people, and we had a discussion the other day, is sometimes you have cases where you are doing a lot of uploads. And so having this asymmetric where download is fast but upload is slow might be a real problem, if you're uploading videos and send them to friends or whatever you might be doing. The other thing I'd say is think about the future. So I mentioned this before, but if you're going to start putting Ethernet cables, what I do is I've got a router downstairs, one part of the mesh, and I've actually got a cable in the cavity wall going up to the loft. And then in the loft, I've got a second mesh router. So I didn't want to go through all that effort getting a cable in and then finding that when I upgraded my fiber package, it was a limiting factor. So no point installing old Ethernet cables. Just these days, you install at least Cat6. Buy devices, particularly smaller devices, really, because 2.4 and 5 gigahertz have different behaviors, as we said. So 5 gigahertz is nice and fast, but not very far, doesn't do a lot very well with distance. And test. I can't say this enough. So if you buy a new broadband package, test, because you want to check for evening dips. What you'll find is you buy an old broadband package and you'll always have a cool-off period, maybe 3 or 4 weeks where you can cancel and then try a different supplier. And actually, this is exactly what I did recently. And I wrote it up. This was my result. So I moved to City Fiber, and with City Fiber provide the fiber into your house, but then you can choose which broadband supplier supplies you with data over the City Fiber. And so this was my first attempt. I used a company called Link Broadband. Link Broadband will provide you broadband over City Fiber cable. And this is what I found. So I've got in here blue, which is the download speed, and green, which is the upload speed. And obviously we got dates. Now what you noticed here is that we get periodic dips. And this is, and these says evenings. So sometimes in the evenings, the broadband actually goes down to 0. This is really poor performance. And this is not to do with a piece of fiber that's coming into my house. It's to do with Link Broadband, the supplier. So presumably some equipment on their network isn't big enough capacity to handle the load.
Peter, that's why I and many other people use Zen as their ISP, because they keep at high speed all the time. They don't. I mean, a lot of this is shaping done by the ISP to try and stop you doing things like videos when they don't want you to.
Yeah. So this is latency again with Link Broadband, and we'll see it's like pretty good. It's like 4 milliseconds, 50 milliseconds, and these spikes correspond to evening uses, as Adrian was just saying. So I tried a different supplier. This is Link. This is Fourth Utility. Exactly the same fiber coming to my house. This was Fourth Utility, and they got a different problem. The download was reasonably good, sort of like about just less than 900. A few little dips in blue, but the upload really did vary an awful lot. And the other problem I had with Fourth Utility is they allocated me a network address which was deemed to be suspicious. So whenever I surfed to certain websites, I had endless problems actually trying to convince them that I'm not a spammer. So, I cancelled Link Broadband after 3 weeks after doing all this testing. I cancelled Fourth Utility. Latency 15 milliseconds is appalling for fiber. I cancelled Fourth Utility after three weeks, and then I eventually ended up on Tube, and we can see Tube here is very different, pretty much flat regardless of time. We get little spikes, little slowdowns, but nothing like the other guys. And remember, this is still the same piece of fiber that's coming into my house. So your ISP choice does actually depend. And as Adrian was saying, Zen is well respected, quite an old ISP. I went with Tube, a bit cheaper. And the tube latency very consistent around the 4 minute. These scales are different, around 4 milliseconds. So yeah, I tested and tested and tested, and then stayed with Tube. So Ray.
Yes, as quickie, what tool did you use to monitor and record all this information?
I had a feeling someone would ask this. So I actually use the official speed test from the company who provides the speedtest.net, which is Ukada, something like that. But they provide a little command line tool. And I actually run this periodically on one of my servers and report it into my home automation. So this is the graphing is done by Home Assistant, and I just run this command line speed test, I think every 15 minutes or something like that. So, but you don't have to automate it, right? You switch to broadband, you get out your phone, get out your desktop, do frequent speed tests, do it during the day, during the night. Try, and if it's poor, switch before this cooling off period finishes. So a little bit more on Ethernet. We've talked a lot about Wi-Fi. Oh, by the way, these tests are over Ethernet, not Wi-Fi. So you've got to test your broadband speed first with a cable. Make sure your Ethernet cable into the back of your router. And then you're probably going to be testing Wi-Fi in your house separately. A little bit more on Ethernet. Even on, I've got a MacBook in front of me with an Ethernet connection onto it. And on the back of it, it's got little LEDs, which gives you some information about what speed the cable's running at. There's different standards with both the cabling and, more importantly, the protocols that go across the cables. So we had 10 base T, which is 10 megabits per second, which you just don't see anymore. 100 base T, 100 megabits per second. And it turns out the only device on my home network that's on 100 megabits per second is my set-top box. Everything else I've got on my network is on 1,000 megabits per second or better. So this matters. I'll show you a picture in a minute. Because if you start buying network equipment, you really want to get network equipment that supports speeds at least faster than the broadband speed that's coming into your house. And you can get 2.5 gigahertz now. Now, if you've got a lot of equipment, sorry, you can of course do everything over Wi-Fi, but probably at some point you're going to have in several devices connected via Ethernet cable directly to your hub. So if you don't have enough Ethernet ports on the back of your hub, on the back of your router, you can extend it with a hub, switch, or router. So a hub is a dumb device that simply replicates data on all ports. And it supports a single network. And they tend to be pretty cheap. A switch, on the other hand, is aware of what devices are on what port and only sends data to the port with the device on. So these are much more efficient. Still only supports a single network, and they can be managed if you want to, configure them in some ways. A little bit more expensive than a hub. And finally, you can have a router on your home network, which enables you to set up new, completely separate networks at home. For example, you might have one network for your financial work. You might have a separate network for all your smart devices, your Alexas, which you may not trust. and a router will pass network data from one network to the other fairly intelligently, and these are even more expensive. So this is what a little switch look like. And hubs actually look pretty much identical, and you can have routers that look identical. All they're usually pretty small. They've got little ports here, they've called, where you can plug in Ethernet cables. So what you do is you get an Ethernet cable, you connect it from your router. At the back of the router, you might have 2 or 3 Ethernet ports. You connect that to, say, the first port, and then all the other 7 ports on this you can connect to PCs and servers and whatever else you might have. And you can see here you've got these little LEDs. They're actually giving you some useful information. They tend to flash when data is going through them, but they'll also give you an indication how fast the connection is. And you can see this here. So this LED is lit up, it's at 1,000 megabits per second. If it's this one's lit up, it's either on 10 or 100 megabits per second. So they give you some clues with the lights it's worth looking out for. And you can see here, this is actually called a switch. So if you want more Ethernet connections at home, personally, I'd recommend just get a switch. These little things are, I don't know, £50 or so from Amazon. Don't bother with a hub.
Sorry, Peter, can I just quickly interrupt?
Yeah.
That one you're showing at the moment, I think is 18 quid on Amazon this morning.
Oh, right.
And the Netgear one is 15 quid. So
okay.
They are.
And those are switches, not hubs.
Have dropped in price tremendously.
Okay. Okay.
Unlike you, I remember the good old days when you had to actually save some money up for them.
Yeah, thank you. Yeah, so don't bother with a hub. And a router is probably for more complex networks where you want to break down your physical network into 2 or more separate parts for a particular reason. And this is a fully connected hub, and you can see the LEDs. The LEDs are actually flashing away in my little server room here. So you take a picture, you take it when certain of them are flashing. But this is what it looked like with all the ports in this case fully busy. So one of these goes to my router and the others go to my little servers. So one of the problems I've got here is the word port is used to mean several different things. So these little connections here, they're called ports. And also we have TCP or network ports, and this is what we're going to talk about now. So let's go back to some very basics. So let's say you're on a desktop with your web browser, Firefox or Edge or Safari or whatever it might be. And you want to get some data off a remote web server somewhere on the internet. Okay, so this web server is going to be listening for inbound connections on a particular port. And for HTTP, unencrypted web traffic, that's going to be port 80, just normal convention. For HTTPS connections, it's going to be port 443. Although, when you type in the URL in your web browser, you can type in https://bbc.co.uk:, and you can actually specify a port number if you really have to, but the default is 443. And then we will have a domain name service, which we've had talks about this before. This is a simple database which does a conversion from friendly names to IP addresses. And all this is IPv4, of course. I'm not particularly going to talk about IPv6 in this talk. So what happens is your browser, you type in bbc.co.uk in the browser window, and the first thing your web browser will do is go to the domain name service and say, who is bbc.co.uk? It'll connect to port 53 on that service. The domain name service will reply with an IP address, this bit here, and then your web server can connect to this IP address at port 443, tries to get the page, and that page comes back. So the only reason I'm doing this is trying to firstly introduce the idea of ports. Port 443 is HTTPS, 53 is a DNS service, and you can see the packets tend to go request, response, request, response. And this thinking matters a little bit. So I mentioned that 443 is the default for HTTPS. on all operating systems, there's a file. On Unix-like operating systems, it's /etc/services. I think on Windows, it's in the Windows directory somewhere. And it's got a list of all the numbers and what they're used for. And, I've only listed the first. So port number 1 is the router table maintenance protocol. Who knew? So this file actually maintains all these numbers and what they mean. I just thought I'd throw that in for info. And certainly on Unix-like systems like Macs and Linux, you'll have a command called lsof, list open files, and that enables you to view on your desktop what different applications are running and what connections they're making. So you can see here I've got, looks like network manager, and it's creating a connection to a different server and so on. So you can actually, sort of query what's going on your network. And you've got a lot of things which are just listening for inbound connections. So again, I just thought I'd share that just for interest. But some of these are displayed as numbers and some are names. The names, this tool is used to look up etc service to convert a number to a name to make it a bit more readable. So mention that in passing because we need to talk about firewalls. A firewall is going to be built into the router that you are using to connect to the internet with. Now, if we look at that case where I said before, but add a router into it, so you are going to make a DNS lookup. So on your phone, you're going to type in bbc.co.uk. That packet's going to go over Wi-Fi to your router. Your router is going to pass it over onto the internet to this name service 888, which is run by Google. That's going to reply. Your network packet's going to come to your router. Your router needs to pass it back to your phone. Then, of course, your router then makes a connection to the web server. Now it's got the address. It sends a request out. Your router passes it onto the web server. Your web server replies, and you get a web page displayed on your phone. You'll notice here that all the requests are started on your internal network. So there is a rule in your box, a firewall rule, because let's think about this. Say a hacker tries to get into your home network. This packet here has gone into your router and to your phone. Why is this hacker blocked from coming in? It's still packets coming into your router, just like these. Well, there's a magic piece of software in your router called a firewall, and it's got a piece of software in there called NAT, or Network Address Translation. And what that does, very clever, it keeps track of when you send an outgoing packet and it gets a response related to the outgoing packet. This firewall pairs those request response together and lets the response come into your network. So if the network discussion, if you like, didn't originate on your Wi-Fi network, then the firewall will block it. Pretty clever way to block it, and it's quite complicated firewalls. You don't have this problem, by the way, if you use IPv6. This is a specific problem with IPv4. So your router should have a pretty decent firewall to actually stop hackers just arbitrarily getting in to your network. Now, let's think of another case. So we're talking before about, you bought a router from Zen, and it's got a telephone port at the back of it. So what's going on there? Well, you can actually plug in a telephone onto that. And what the router will do, it would actually listen on port 5060, which is the voice over IP, the session initiation protocol. It will sit there listening for telephone calls to come in. So if someone's calling you, you'll get a network request which is trying to go through your firewall into your telephone to make your telephone ring. Now, of course, by default, your firewall is just going to block that. Incoming connections are going to be blocked. So in order to allow telephones to work on your internal network, you're going to either have to manually configure your firewall to allow incoming messages on port 5060 to get redirected to this guy, or what actually happens usually is there's this protocol called universal plug and play. And if you enable that in your router, your telephone, your router that provides your telephone service, whatever it is, whether it's built into your main router or separately, it doesn't matter, it will request a configuration change on your firewall so that when your SIP server comes in, it can talk directly to your phone and it can ring your phone. So if you've got servers running internal your network, it might be a voice over IP server, it might be a web server, whatever it is, incoming connections either need to be manually configured in your firewall or using this universal plug and play mechanism so that devices can configure the firewall on your behalf. So hopefully that makes sense. Most people don't have incoming connections, but if you do, if you want to have a voice over IP or a web server, then you're going to have to think how you're going to configure your router, or are you going to allow the UPnP to configure it for you? By the way, many experts on networking think that both network address translation and universal plug and play are just evil. They go against all the principles of networking, but the point is they kind of work, at least for IPv4. IPv6, which most of us should be using now, doesn't have these problems, and so you can get away with lots of these. Ray.
Are you going to talk about connecting NAS to the network and allowing access remotely?
Not specifically, but that will have exactly the same concern. So if this was your NAS, and let's say you want to give it a web interface or a web DAB interface, then you'd have to configure your firewall to allow someone who tried to connect in at port 80, let's say, you have to configure your firewall to pass through packets for port 80 into your NAS. And I'll fire up my router configuration. I'll show you how to do this sort of stuff on my router in a minute.
Thank you. Yep.
Okay, so firewall configurations. I've got some screenshots. So most routers, apart from ones from Amazon, have a web interface. So you can usually go to something, your local network address with a .1 at the end of it. And it's usually printed at the bottom of your router. So, you you look at that. So mine is 192.168.175.1.
So if you just like to carry on, that's fine.
I'll just mute him. And then you need to log in. Again, by default, the default username and password is usually printed on the box. And of course, you can only access this from internal your network. So if someone's trying to reconfigure your router from outside, the router won't allow that. So this is lots of complicated configurations on my router. And I've got an Asus router which has oodles of features on it. But here we've got an example. Here's the network map. We can see we've got two meshes here, or two nodes part of the network. We've got the base one and the node. We can see our network configurations. We've got a whole bunch of different configurations we can look at, different wireless settings, firewall settings, whole bunch of stuff. Generally, the defaults are going to work fine, but if you want to do something like run a NAS, then you will need to dive in here and do something. And I'll actually fire it up in a minute and we can have a little poke around. So allowing in incoming connections. So for example, hosting a personal photo album, which I do, you're looking for in your router configuration, something called port forwarding, or sometimes called virtual server. IPv6 doesn't have the same sorts of issues. So you're going to have to think about IPv4 connections and IPv6, probably. If you're on fiber, you may not be able to do this because your router doesn't have a unique public IP address. The CGNAT, we talked about this before in a different talk. You may need to pay extra for a public IP address, which is unique to you, but you can pay extra for that. And I had to pay extra for that. Some companies like Virgin Media do this anyway, give you a free personal IP address. Otherwise, if your ISP uses CGNAT, then you're going to have to buy for a static IP address. Or if it's just you can run a VPN server. And I'll step through the actual configurations in a minute, be a bit more obvious here. So other security considerations for your network. So you probably want to think about turn off any unneeded network services on your desktops. If you don't use the remote login facility on your desktop, turn it off. If you don't use file sharing, turn it off. Viruses and malware protections, definitely for Windows. I would say this is from partly experience and partly sort of internet wisdom, if you like. But it's actually debatable if you need virus protections on Linux and other Unix-like operating systems like Macs. I don't run them. I don't scan for viruses. I don't have an antivirus on my devices at all. Unix operating systems are built much more securely than Windows. You can also run a firewall on your desktops. And I find that like an odd thing to do, really, because you're sitting behind your firewall at home. Why would you want a second firewall? I suppose if your operating system is fragile, then you might choose to do it. I don't. I just always turn off desktop firewalls and rely on a nicely configured router to protect my internal network. And we talked about trackers and ad blocking. So lots of sites, Facebook notably, and Google and the rest of them, as per recent talk about real-time bidding. These companies are funded by advertising and targeted ads. So they want to do two things. They want to track who you are and lots of data about you, and then deliver targeted ads to your desktop and have it embedded in it. So you might choose you want to block these. And one way to do this actually pretty easily on your whole network is to create a little DNS server on your network that blocks any DNS lookups of companies which are ad related. And there's tools like AdGuard, Home, and Pi-hole that will do that for you. And you can install browser plugins and desktop applications, things like Privacy Badger and so on. That will also block these trackers and ads. I'm not going to go through because we talked a lot about that recently. So other things that you might be on your to-do list, on your considerations, there is a configuration of firewalls called the demilitarized zone. We have an internet connection, you have a first firewall, then you have what's called a demilitarized zone, and then a second firewall before your internal network. And the idea is that in the demilitarized zone, that's where you put your NASs and your web servers and such like that. So it means that if those servers are hacked in your demilitarized zone, they still got to go through a second firewall to get onto your public network. And companies will typically, have this sort of configuration, but for homes, it's a little bit overkill. I mentioned before on your router, you might allow guest network so that when people come to your house and want to access the internet, they can use the guest network, but don't have access to, your financial information on your network. You might want to have a custom DNS and DHCP server. These are both usually provided by your router, but there are some advantages to having your own little local DNS cache. It can speed up certain lookups. If you've got switches or routers, you can create additional virtual local area networks. In other words, two networks over a single physical network, if you know what I mean. And so you might allocate one VLAN to visitors and another VLAN to your finances and another VLAN for some other purposes. And if different uses of your home network are on different VLANs, then they're completely isolated from each other. So these days, people doing home automation are very suspicious about all these internet connected devices that you buy. They seem to be calling back to manufacturers in China and stuff. Put those on a VLAN, and then at least you know those devices on your network are not going to interfere with anything else on your network. Well, I mentioned this in passing. There was an older style of firewall called a proxy firewall, which no one uses anymore. People make use of a NAT-based firewall. But a proxy firewall is you have to configure in your browser so that when your browser wants to make a request, it sends a request to your router, and then your router will then do a request on your behalf. It's a bit of a funny one. So here's all the references, and I think I'm going to jump straight into looking at my router configuration. So, feel free to ask questions just while I go through this. So this is my router configuration. And lots of different menus. So we can have a look at the network map, have a look at our mesh configuration. So we can see I've got two routers on my mesh, and I've got 15 connections on one and 10 on the other. And most of the connections over Wi-Fi will just connect to the nearest mesh router, whether it's either downstairs or upstairs. What else is interesting in here? So we can have a look at our firewall configuration. Let's say.
Sorry, Peter, just quickly jump in.
Yeah.
Yeah. Is that a hardwire connection between those two routers?
Yes, I've got a cable between them in my cavity wall connecting the two together.
Okay.
But they can connect via a separate band on Wi-Fi. So that's a common when you set it up, you can choose which to go for.
Peter, do you know an easy way to tell the difference between a Cat5e or Cat5 cable? When you buy cabling, they're marked, but if you
Yes.
have pre-made cables, and I seem to have dozens of them lying around, and they don't seem to be marked. Is there an easy way of identifying them?
No, if they don't have it on, let's I've got a cable here just lying around. Right, I'll stop sharing for the moment.
If you buy the cabling,
I don't know
it
if you
usually
can
has it
see
on.
this,
Yeah.
but this actually says Cat5e on it. This particular cable, and it's printed periodically on the cable. So if it's unmarked, then you can probably assume it might only be Cat5, not 5e.
Can I just throw in two pence worth there? If you're on the short cable runs, you probably get away with the Cat5 running even up to 10 gigabits per second. It's actually increased length, and you get the problems with capacitance and things which reduce the speed performance.
Yep. Let's go back to share. I don't know what else you want to see from my router, but let's have a look at the port forwarding. It's not in there. It's in. Yeah. So if you've got a phone server or a NAS or a web server, you're going to want to allow incoming connections, and this particular router calls it a virtual server. And so I've got a list of these forwarding. So for example, HTTPS, external port 443, I redirect that to an internal server. That's the name of my internal server. So if you make a connection to my router at port 443, you're actually going to connect to this device, which is on my local network. And don't have SIP listed here. Got WireGuard, which is my VPN. I do allow incoming emails. I run my own email server, so I've got those configured there. Now under
Peter, quickly again, would you put your NAS in there with a
Yes,
particular
if you
port
want to
number?
expose that to the outside world. You may not want to, you may choose to. So what I actually do is I actually pay for a static IP address, which means the IP address of my router, the public side of the router, is fixed. And I've actually paid for a domain, plord.co.uk. And if you do a DNS lookup of plord.co.uk, it comes to the address of my router. And so if you make a, go into a web browser, https://plord.co.uk, that will come to port 443 on the public side of my router. The router will then forward it onto my internal web server. So your NAS, depending on what protocols your NAS is going to support, you'll need to do something similar to that. What else do I want to show here? IPv6 works differently. We talked about IPv6, not going to go into, oh yeah, so what I did want to do is system log. So these are actual port forwarding in action. And this includes any port forwarding that's been set up by the plug and play protocol. They get listed here. And in fact, all of mine are currently manually created by me. So lots of features, as you can see on this particular router. So I bought it because it's got those features. Even though I don't use them, I can do in the future. But more important, it supports Wi-Fi 6, so it's nice and fast. It does a mesh, so I get good coverage in my house. Right. Tell you what I'll do, I'm going to stop sharing now and let's have any other points of interest, any discussions, points raised. So hopefully that was a good range of subjects. And as I said to start with, what I try to do is to present a few things to, trigger discussions. And I'm hoping that other people can answer the questions as well. So Paul.
Sorry, Peter. I missed the last bit on port forwarding. I had a call came in that I had to take. If you could just briefly say why you would do that. But secondly, I think there's been some debate about whether to use a router firewall or whether to use the firewall on your box, hasn't there? Because it's confusing. The terminology says block all incoming connections, which can imply block all connections that are started by something else, or could imply block anything coming in. And of course, you've got all the web responses and everything else coming back down the system. And what they don't tell you in their manuals is what it's actually doing in the, at the hardware and software end in any particular detail.
Yeah, so NAT-based firewall, we did have a slide on that, maybe you missed that. But a NAT-based firewall, what that does, it pairs outbound requests with the responses. So it allows in responses that were originated on your internal network.
Yeah.
So it actually tracks connections with time and some quite fancy stuff.
And does it know to expect sometimes that you send on one port and expect to return on the other, on a different port?
Yeah. It's pretty sophisticated. But as I said, network experts really hate it because it's basically non-standard. It's a solution to a problem that has largely gone away. Now we move to IPv6.
So do you know whether the built-in software on the router, would it say whether it's a NAT-based system or not?
Yeah.
It would. Okay.
Yeah. You'll find the word NAT in there. There'll be a tick box. Let's go back to share and let's see if we can find it. So if I go,
I've just been looking at somebody's router today for them, and it was the amount of information was extremely bland and scarce. It was a very simple interface.
Yeah. So here I've got enable firewall.
Yep.
So somewhere in here will be that's my IPv6 stuff.
So the enabled DOS protection is presumably stopping it being repeatedly hit by some attempt to get in.
Yes, I've got a tick box there to enable NAT.
Yep.
Which is effectively part of the firewall, and enable the plug and play as well, so that internal sites can provide a service.
Right. I mean, on IPv4 we've got NAT operating in the background all the time anyway, haven't we? Because of the
Yes,
subnet that you
yes.
use inside your own network. Yeah.
Okay, let me just stop sharing.
And you were saying about port serving, port forwarding.
Oh yes, the port forwarding. You can see that, and my service called virtual server stroke port forwarding.
Oh, okay. So you're forwarding for stuff that's going into the into the proxy effectively, and then back out again.
Yeah. So I've got a public static IP address.
Yeah.
You can use DNS to find that IP address, and plaw.co.uk will resolve to the public IP address of my server. Then if you try to connect that on port 443, for example, in your browser type https://plaw.co.uk, that packet will come to the outside of my router, and the router is configured here to forward it into an internal server, this IP address where my web server is running.
Yeah, okay.
And you see I've got several other ports which do go to different servers internally. So for example, I've got a VPN server running on this server, 192.1, and so if I'm out and about, I can start the VPN client on my phone, or I can connect to my internal network. And that requires allowing in port 51820 into this particular server. And IPv6 doesn't have this sort of problem because every device has got a unique IPv6 address.
So are the routers now defaulting to IPv6 if they can use it, and back to IPv4 if they can't?
Good question.
Because we're still in transit, aren't we, to some extent?
I think last time I saw, all the big servers now support IPv6. I think it's something like 40% of network traffic is now IPv6, 60% IPv4, something like that. There are some big exceptions. Virgin Media doesn't support IPv6. GitHub doesn't support IPv6. So when this router arrived, it was pre-configured to enable IPv4, but IPv6 was turned off.
Oh.
But when I turned it on, it all worked, So obviously CityFibre and my ISP do fully support IPv6. So if possible, I'd recommend setting up your router to support IPv4 and IPv6. So you can connect to plaw.co.uk over IPv4 or over IPv6. And since you mentioned that, we got to it's a weird place. Yeah, so I've got IPv6 firewall configurations here. So again, if anything comes in port 443, it gets redirected to a local IPv6 server. Okay, so Mark.
You mentioned you were using a command line tool to monitor the speed of your service.
Yes.
It didn't say what it is.
Yes, I mentioned it. Let me, can we actually do that? We probably... I'm wondering if I can actually... Okay. No, I can't put my hands on it right now, but it's the same. If you go to speedtest.net, that is hosted. Let me just look it up. That is hosted by a company called Ookla, Ookla, and you can actually download tools from those for lots of different applications, including command line. So on my Linux server, I actually run the official tool from this company, Ookla, and I run that periodically to measure the broadband. So it's exactly the same as if you're running speedtest.net application or speedtest.net in your browser. Let me
Yeah,
just.
but I was just thinking, if you run it from the command line, then presumably you can capture the responses to a file.
That's exactly what I do. I capture the responses to a file and I push it to Home Assistant, which plots it. So this is speed.
Because I mean that gives you the option to run it periodically over a 24-hour period to detect those, you
So
know,
let's have a look at
but
my
service fail, when the service is dropping off.
Yep. So this is my
That's
Home
what
Assistant. So this is where those numbers, as you were saying, gets fed into it. So this here is download and upload over the last few days, and it's pretty constant. You expect little dips occasionally. Latency was 4 milliseconds. It seems to have dropped to about 3 milliseconds. And this is a graph which is speed per time of day, which I'm trying to see if the broadband is slower in the evenings or whatever. And you can see over time of day, we get a few dropouts in the early morning, but very, very few.
Yeah, thank you.
Okay, so Russell.
Yeah, I'm part way through a migration from Virgin Media over to fibre, and boy, it's painful because you've got the three parties to deal with: Virgin Media, OpenReach, and the new ISP, which is Andrews and Arnold. And yeah, I've been cut off for several days, and it's come back again. And anyway, however,
Didn't you get your fibre up and running before you disconnected from Virgin Media?
I did not disconnect from Virgin Media. They did because anyway, it's horrible. Hopefully, once it's all done, it will be wonderful. But at the moment, it's all a bit fraught. But what I was going to ask, you mentioned your Wi-Fi analyzer tool. I was just looking on the Apple App Store because I wasn't aware that there was one that would run on iOS. There's actually quite a few listed. And they all look like they might be rather flaky. I just wondered what the company is that your one might be listed under.
I can probably find that out. Wi-Fi. It's open source basically. I've just started up here actually locally. Let me see if I can find it. Yeah, I think that's it.
It's VREM software development. Victor Romeo Echo Mike software development.
Okay, you found it before me.
Yeah, I got it on my phone.
Yeah.
And if you go to com.vrem dot Wi-Fi analyzer is the what looks like the web address.
Okay, thanks for that.
Oh yeah. I've got it here. Let me just share my screen. So I've just found that as well. I've had it installed on my phone for so long, I forget where it comes from. So this is the Android App Store, and it's open source Wi-Fi analyzer. I got lots of different screens actually giving you different things. But as I say, the one with the arrow in and the noises are pretty useful. Keep it simple,
Good, thanks.
But there are alternatives, and I've got a few. And there's a good one from one of the router companies. I might be able to find this and post it, but it allows you to draw a map of your house, of your rooms, and as you move your phone around a room, it actually tracks the Wi-Fi strength in each room, so you can actually go back and have a look at it. If I find that one, I will share it on the page. Okay, Mary.
Well, my question's about the extenders.
Yep.
Because we've got them we're with BTE because I used to work for BT. But my husband switched us to a digital line before consulting with me. He didn't realise what it totally involved. And basically, we've been told that if we move, our old extenders won't work. So basically, we don't have the digital line working at the moment because we want to use the old extenders. Because if we stop using them, they want to pay us to rent some. They're saying nothing else will work.
I can think of no reason why extenders wouldn't work with your new router. They may well need to be reconfigured to your new network name.
Ah, okay.
So hopefully you can online dig out the documentation for these
Yeah.
devices,
Yeah.
and maybe a case of resetting it and then using an app on your phone to reconfigure it to your new network name.
Will do.
This is one reason when I set up networks, and I've done this for years and years and years. When you get delivered a router from a company, they give you a default network name, which is printed on the bottom, which is, ZX953X or something. And I always go in and rename it Pete's WAN. And so if I change my router, I'll change the router and give it the same network name, so I don't have to reconfigure the rest of my network.
Yeah.
All the Wi-Fi name and passwords for existing devices will carry on working, even though I've changed my router.
That's a good idea. Thank you.
If I can just throw in a quick word of caution there. I mean, Virgin Media played a similar game with Wi-Fi extenders or repeaters, whatever they're called, and they are uniquely set up for your account. And I gather modifying them is impossible, or it's a nightmare if you can find information.
Oh, okay. Because we bought ours separately, you see. So I'm presuming because we bought them separately, they weren't configured for a particular account.
Not from your provider.
No. Well,
they're independent in that case.
Actually, yes, they were from the provider, but they were purchased sort of via their accessories store, if you know what I mean.
Yeah.
Yeah, I've got one here actually. I don't know if you can see it, but it says 200 megabits per second power line.
We've used some of those.
This actually connects. It sends the data over your electricity lines through the back of it. So they come in pairs. You put one by your router, and then one somewhere else on your network.
Okay.
And then you can get Ethernet on the back.
Yeah, because we've got these things.
All right.
And basically,
they may not be extenders. I wonder if they are.
They are. Yeah, because we've got them upstairs as well.
And what company are they made by?
Let me have a quick look and see if it says. It just says BT on it, so I don't know who's actually made them.
Oh, right. Yeah. So given it was supplied with your old BT network, you may not have the option to change the configuration.
It may have been confined, shall we say.
Yeah. So what I would do if I were you, I would look at the manufacturer of your new router and see if you can get a mesh add-on to it, maybe of the same manufacturer, but at least different manufacturer that talks the same mesh protocol. So if, for example, when my parents moved to a new network, they were supplied with a Amazon router, Eero or something like that. And you can buy them in like packs of 2 or packs of 3. Right. And they work together as a mesh, and you just put them in different places in your house to get the coverage.
I'll have a look at that. Thank you, Peter.
Neil.
Okay, so just carrying on that one. I've recently I recently put in a mesh network for a shooting lodge in Scotland. As I was off on holiday up there, I recommend the Deco devices. They seem to work pretty damn well. And just a couple of tools that people might find useful if they're trying to get through networks into and out of their house. Duck DNS is quite a useful one for retargeting a dynamic IP address to look semi-static if you want to get out, and your router may well provide a dynamic DNS input that you can use with it. And the other major tool that I've used in the past with CGNAT systems is Tailscale. So if you want a tool which can get through your network, then Tailscale is one very worth looking at.
Yep, thank you.
Okay. Thanks.
Russell, again, you got your hand up.
Yeah. I just wanted to follow on the power line adapters, which I used to use, and you can do more than a pair. You can have three or four of them, and they will mesh. But they do some pretty nasty things to what they're imposing on your mains cable, on your main system. And I've got some vintage B&O hi-fi, and I couldn't understand why I was getting a little burbling noise. I spent ages trying to work out what had gone wrong and whether I needed to replace some capacitors or whatever, until I unplugged my power line adapters and the noise went away. So I don't use them anymore.
I was going to say, the power line adapters, we didn't do any damage, but apparently my hair straighteners do.
Okay, so I'm just flipping through the chat window to see if there's any questions on there. Lot of stuff we've covered before that. Current BT fiber to the cabinet, which is on your street usually, then copper to the house. So Virgin Broadband do the same thing. So it's actually fiber to the green box at the end of your street and then coax to your house. Depends on, okay, so satellite latency very much depends on your sky view and your orbit. You can do voice over IP over any internet connection peer-to-peer. You're paying for the fixed number and the back end routing to and from other numbers on the old telephone number networks. I'm just flipping through this to see if there's any kind of things that we've not really talked about. I also use Zen Internet. Yeah. Okay. Yeah, I think we cover most things there. So, so if you want to verbally send anything, say anything, please do so now. Oh, Adrian, sorry, I didn't notice you there.
Yes, I'm not sure what other providers do, but Zen, who use Fritzbox routers, do offer a rental system for a mesh, a Fritzbox mesh. But of course, they're quite expensive to get it regularly paying for it. You can buy them and there's no problem. Zen will quite happily, I mean, you can set them up yourself, but they're happy to tell you what you need if you've got a problem with them.
Mm-hmm.
So I don't think it's worth renting it.
Yeah. Yeah. Okay. Any other points for anything else?
I was going to say something.
Yeah, Roger.
This is slightly random, but firstly, thank you for very comprehensive coverage. Thank you for not starting at the beginning of time. You know, because we have come a long way. Here's a nice little tip. I've used it for years, and we did it on holiday. I had an eSIM in the phone, so the eSIM allowed me to use internet while I was in the States.
Mm-hmm.
Okay.
Yes.
This is a coming in thing. It's the thing to do. Anyway, the thing was I didn't give it to my wife. She didn't have an eSIM because we just had enough on my phone. So when she needed to use internet, and that was when we were walking around in the streets even, I just turned on the personal hotspot. You with me on that?
Yep.
You've got a personal hotspot, and this phone then beams out Wi-Fi to her phone. The thing about the personal hotspot is that you can set the name of the SSID thing.
Yep.
And you can set the password.
Yep.
So in your case, you would set it to Pete's WAN and your local password. So it matches the password that's already on her phone, so that when you turn on this hotspot and say you open up your laptop is going to pick up the same Wi-Fi credentials that it would pick up when it's at home. You got me?
Yep. Yep.
Yep.
Makes perfect sense. Yeah. Logical. There is There is a device you can go onto Amazon. You can get a device which they typically call a travel router, and it's similar to what we've already talked about, but instead of having, say ADSL on one side and Wi-Fi on the other, it's got Wi-Fi on both sides. And the idea is that if you go into a place where, Wi-Fi you have to pay for, you get one of these travel routers, you pay for one sign up. So the travel router is the person who connects to say the hotel's Wi-Fi, and then all your family devices can then connect to your travel router. So you can do that with your phone, or you can buy a device specially for it. Tony.
Yeah, there's a question I put on the chat. I've got a Canon GX printer, and it sits right here, and within a meter of it is the router. And I've got a extender downstairs. But when the printer powers up, it recognizes the repeater downstairs rather than the router that's just a meter away from it. How can I get the printer to always connect directly to the router first time?
Does your router have a different network name to your main router?
They're the same. They share the same name.
Oh, right. I would honestly expect your printer to go to the router with the highest signal strength.
Yeah, that's what I thought. It appears not to be the case.
I don't know how you change your printer configuration to force that. Presumably it still works, but just
well, no, it does. When it logs on to the extender, the signal quality is so low it doesn't print properly. So it doesn't work properly.
So it may be a problem with your extender. Perhaps your extender has got a very high signal strength, but a poor connection back to your router.
That's a possibility. I can look at that. Okay, thanks.
Mark.
That speed test thing, is it called speed test -CLI? I found that.
Yes,
I
I
found that's
believe
made
it is.
by the Ukula.
Yes, that's right.
Okay. Right,
Somewhere
just
on the
wanted to
website
check.
you can download the
Yeah, I
command line
found it,
versions.
but I just wanted to check whether I'd found the right thing.
Yes,
Thank you.
that's exactly right. Yes, thank you. Thank you for confirming that. Okay, anything else for anyone else? So next month Paul, sorry.
Sorry, it was just an addition to that. That Which also do a broadband speed checker. One thing to be aware of actually is some of them are a factor of 10 in disagreement with each other, and I think that's down to the fact that some are measuring megabytes per second and some are measuring megabits per second.
Yeah.
And of course, you've got the overhead bits and you've got 8 bits and a byte and that kind of thing, which kind of explains the roughly order of magnitude difference between them. And that's just something to be aware of. I'm consistently getting 150 meg up and down on my router, and that's what I'm paying for. But I can't remember which one, but one of these speed checkers actually shows me about a tenth of that. And again, it's consistent, and it's just because of the terminology. One's using megabytes, one's using megabits.
Yes, it's a good point. I did mean to raise that. So officially, network speeds are measured in bits per second, and that is usually indicated by a lowercase b. If you see an uppercase b, it's usually bytes per second. And as Paul was saying, you'd normally assume there's 10 bits to the byte, so the bytes per second be 10 times slower than the bits per second. So it's just a conversion, same speed, just converted to different units.
Yeah, and the other factor, of course, is the error correction bits and all the other stuff that's in the background and in terms of the noise. And I think when they're running these tests, they tend to stream a whole load of data at once, don't they? There's no ramp up and ramp down time effectively, other than at the beginning and at the end of the whole stream.
Yeah, there's lots of different test tools that do slightly different things. I mean, the speedtest.net, what that does, initially it tries to find the nearest server by latency. So it's got a list of loads of test servers, and it finds the nearest one, in other words, it's got shortest latency, and then tests to that.
Yeah, you're right. And the other thing to be aware of it doesn't need saying really, but it's easy to forget. If you're testing your mobile network and you're running low on data or you're roaming overseas, you can actually use quite a lot of your data allowance by running some of these tests, because it's chucking if it's a very fast connection, it's chucking quite a reasonable amount of data at the network for several seconds, which can actually blast into your data allowance. But it's just something to be aware of. It took me over my limit once just running a speed test.
Yeah, good point. Okay. Anything else for anyone else? Great. So in that case, let's say goodbye, and we'll see you next month when we're doing 3D printing. Something completely different, a bit more physical rather than all this software malarkey. See you next time.
Thank you, Pete.
Thanks very much.
Bye.
Thanks for
Thank
your
you.
work. Great, fantastic.